Hi guys, welcome back to the shop. Hey, today I'm going to build the crankshaft for the RM 400. I've got to tear down the one that I suspect is good, and we'll build that one back. But before I do that, I want to do a little bit of an experiment, and I'm going to show you what that's all about. It has to do with that crankshaft and whether or not I can use some components that I have. So let me get you overhead over here and we're going to take a look at this thing. Okay, as you can see here, I've got half the case put together, and I've actually installed the cylinder and the piston. And what I'm looking for here is, see these, the crankshaft on these are centered by the piston instead of by the thrust washers down here at the crankshaft big end. And what I wanted to make sure of is that I have clearance, so that I'm wanting to see if this matters. And I can tell you right now, it doesn't matter one bit. So that determines whether or not we can use these crankshafts. I've got two of them that have this water damage. I mean, here's one set right here, and I've got another set that has the same damage. So let me get you over here with the other camera, and I'll show you what I'm talking about. So when you assemble this crankshaft, this is how it goes. So you've got the bearing and a washer on both sides, but it's really not a thrust washer. I consider that more of a dimension correcting thing. That's really about the only reason those are in there. A regular thrust washer, it performs a completely different task. Okay, get you up here close, and I'm pulling this crankshaft as far as I can to the right, and I know it's real hard to see, but we've still got a gap there, and that gap is just about the size of the, I call this a thrust washer, but it's really not. This is the washer that goes in on these right here, and they're actually the same size as the bearing, so they can move all the way to the right or left if you want them to. But the piston captures that, so they never will go past. I'm looking at they just barely go to the edge of the bearing. And I've got this all the way in there. So it's just about the width of that washer. So it never goes to this surface at all. So these are perfectly good to use. Okay, let's take a look at this. Okay, right over here is the washer, and you can see that it floats in there. I think you can. See there? Okay, so that's not tight. And this one's same way. You can actually see it move, maybe not on the camera, but when you move the rod, it's moving with the bearing. But you see how that slides all the way over. So if indeed you actually had to have these surfaces, you know, you would have to make sure they're in good shape like this one. Okay, I'm going to go ahead and take a measurement of the space between the half and the washer, or maybe between the bearing and the washer. Let's see if I can get that to move over. Yeah, it's a pretty wide gap actually. Looks like it. Let me get my feeler gauges. Okay. Let me get another light here. Hopefully you can see that. Now, Suzuki doesn't give me this dimension. So it's a gee whiz dimension. So I'm getting 24 thousandths in there. 0.61 millimeter. And it doesn't give me that, doesn't ask me to take that measurement or anything. I just wanted to know what it was before I tore it apart. And the dimension that they give you is 70 millimeters right here, plus or minus the 0.1. And that's the only dimension that they're worried about. If that's right, everything else is right. You know, not without saying the run out. Of course, you got to check the run out, and you got to remove that. But 70 millimeters is what we're looking for, and we know now after our little mock-up that these surfaces out here, you don't need them. Okay, a lot of I'd say probably around 75% of them are built this way. You know, the bearing goes into the rod, and then you've got a thrust washer, a real thrust washer on each side. And these are not centered by the piston. These are centered by the design here, the thrust washers on each side. That's why you've got to have a dimension between them. They can't be solid. Now, don't get me wrong, this type does that also, but I think it's primarily designed just so this doesn't, when this heats up, that it doesn't swell up and lock up. It's a completely different dimension, pretty small if I remember right, like maybe 6 thousandths. And these here are more like 18, 16, 18, something like that. But the design is completely different, and that's just what I wanted everybody to see on this, was that the rod is never going to come over here and hit this. So if you've got a crankshaft that's damaged like this, you can use it without any problems with this design. Okay, so here's the other set here. You can actually see the indentation of the washer where it was at right here. And it really never looks like anything ever touches this. Now, I suspect that maybe they use these halves on a different crankshaft, maybe, I don't know. But, you know, where maybe you do use those. But if I remember right, I think these are RM 400 only. But you just never know, you know. This is the worst one. But anyhow, we're going to use the, I think, we're going to use the one that we're going to disassemble here. So let me get this taken apart and then we'll get right with that. Okay guys, don't forget the thumbs up. Okay. So our crankshaft dimension is RM 400. That's an N, and the one I'm doing is a T, but they're the same. 70 millimeter, 70.0, and it's plus or minus 0.1 millimeter. All right, let's see what we got here. Okay, 70.03. So we're good as we're going together. Just take a look here for gee whiz. 70.07. So we're good, and we've got good dimples. Even though that one's kind of full of stuff. It's, yeah, grease. We'll be cleaning this up in the vat anyway. And this is the one that when I tore it apart, I wasn't so sure about the seal surface, but it actually looks okay. I took some crocus and worked it down. You can see some little specks in it, but I think it's gonna seal all right. Now this one would be a good candidate for a Speedy sleeve. You know, when your bearing is bigger than your seal, you can do that without any issue. I actually have one here because I'm probably going to do one on one of the others. This is your Speedy sleeve. See, when both dimensions are the same, or you're sliding the seal onto the same one that you're sliding your bearing onto, if you use a Speedy sleeve, anytime you take it apart, for a bearing anyway, you're going to have to remove the Speedy sleeve in order to get the bearing off. So you're going to have to do this again. These are, they're not terrible, but they're about 25 bucks. But when you've got one that's stepped down like this, you'll never have to remove that. And here's, if you don't know, they come with a little driver, and you just drive that on. And then this piece back here, you can remove it, the part that you drove it on with. So all that's left is just this. So this is one that would work on this crankshaft, but I don't think we need to do it. I think we're going to be okay. But that's a Speedy sleeve if you've heard about it but never seen one. And in this case, it's a 99092, and that's SKF, the same people that make a lot of the American bearings. So we've got good bearing surfaces, good seal surfaces. The keyway is in good shape. It holds it in there good. And we've got good threads. And the ones on this side are left hand. So if these are messed up, it's a little bit more of an issue than it is on the other side. All right. Make sure you hold it on the bottom, and make sure the rod is clear, especially if you're going to reuse it. Okay, so there's our rod. Doesn't look too bad. Got a little pitting maybe. And there's our 2 washers and our bearing. And the surface looks real nice on this one. So we'll go ahead and press that on out. Press the pin out. Okay, now we've got everything taken apart, and you can kind of look here. See, there's no trace of any spinning here on this one at all. You can definitely see where they heat treated the pin area. I ran into that on the RM 250. There's no way you're going to cut this unless you got some, I don't know, probably carbide or something might do it, I don't know. But the rod also, no sign of any touching here. Let me get you a little closer. Yeah, I think you can see it. Just really no sign of any spinning at all. Definitely see the heat treated area. Okay, the first thing, we just check our rod, make sure it visually looks the same lengthwise. This is a new Vintco. And let's check our pin. 6978 for the old one. 6976. And the diameter, of course, 24 millimeter. .24 millimeter. 1976. That one's a little, not going to matter, but it's a little bit narrower. 2. A little over 2. Oh, that one's even bigger. And that's a used one. So I don't see anything there that's going to cause an issue. Now I'm gonna take the halves over clean them in the solvent tank, and then I'll take them over to the wire brush. That's usually what I do to shine them up and clean them up, and then we'll put them in the ultrasonic cleaner after that. Okay, let's just weigh these out and see what we got. The original Suzuki one at 155 grams, and the Vintco 147 grams. It's pretty close. I kind of like seeing them a little bit lighter. That gives you a little more RPM. I mean, not that you're going to be able to measure it probably, but you know, it's less work on the engine, and everything should last longer. It's just a win-win. Thanks, guys. Don't forget that thumbs up. Okay, I've just washed all of these parts in the solvent tank. All this is good and clean and dry, and I've also just pulled these out of the ultrasonic cleaner after I did a clean in the solvent tank, and then with the wire brush. And that's what usually makes them so shiny. I mean, I'm not going to go to the point to shine it all up, but it's all clean and rust free, and we're good to go on this. Now, the one thing that, take a note here, these are essentially flat, where you can see that it's been turned here. From there to here, there's probably a couple thousandths, but it's really close, so I'm not going to worry about shimming these. I just think that it's so minimal, we don't even need to worry about it. And you know, you can actually see there's a little bit of corrosion, not corrosion, but the pitting there. But these, you know, you just see no sign of that spinning or turning here. So those that have that a high degree of corrosion there, I don't think there's any need to worry about those. If you want to use them, use them. And I'll probably use one of them because I just wanted to mock that up and see. I knew that they centered off the piston, but I just wanted to make sure that there was just no doubt that it was moving over into the area where the washer was, and it's not. So if you want to use one like that, I just don't think there's any problem with it, and I'm going to do it when I build up my next crankshaft. But for right now, for this one that we're using, we're going to put all new parts in it. I'll be using a used crank, or probably a used rod, this one right here, in my spare. Of course, the bearing and pin and everything will get replaced, but I think this is a good rod, and one of the others that I tore apart was also good. So we'll be using those, but this one, the main one I'm going to use, I'm going to go ahead and put a new Vintco in it. So I think the next thing we need to do is take a half and a pin and go over and put the pin in that first half, and then we'll build it up and go ahead and finish building it. Okay, I've got my mag side over here, and I'm just going to go ahead and put a little bit of light oil in there. And we're going to be pressing it over the beam here. All right, get our aluminum pusher in here. is. It's a hard push. Just right flush with it. Okay, got our half with the pin in it, ready to go. So we'll go ahead and load the crankshaft. We'll start with a washer, and then we'll get our assembly lube inside and out. And we'll get our other washer in there. Remember that rod just slides right over the. And get us a little bit of assembly lube inside. Okay. And there it is. Okay, see you back over at the press. Okay, we're all set up here. Aluminum pusher. I'm just going to bring that down pretty close, just kind of so it'll not move a whole lot. And then, as I always do, I'll try to get this as square as I can. I know they've got these fancy little alignment type jigs. I see them on YouTube and Facebook and whatnot. But I don't know, to me it's just a lot of stuff in my way. It probably gets them a little closer, I don't know. Never used one, probably never will. But this gets it pretty darn close. Okay, so I'm happy with that. Let's see if it'll push on in. Okay, I'm going to let that air compressor quiet down, and then we'll be back. Okay. Yeah, I just don't like trying to talk over that thing. Okay, see what we have for clearance here. Everything is still loose. You can see it moving up and down. That, if you were used to the other type of thrust washer type, you'd be a little concerned about all that. But we're going to go between the bearing and the washer. I refrain to even call this a thrust washer. And Let's see. Okay, that's tight right there, and that is 17 thousandths, 0.43 millimeter. Remember, we had about 24 on the other one, so I've popped a little bit further with this. I think first thing we need to do is just pull it out and see what the webs measure. That's the big indicator anyway. Let me set that this way. Okay, we're at 69.93, so it went in a little bit farther, but that's still acceptable. We've got plus or minus 0.1 each way. But what I'm going to do is I'm going to spread it just a little bit because I want to be as close as I can. Okay, to do that, I take two machinist wedges, and I get behind the rod here, and I'll just go ahead, pound them down pretty good. See where we're at. Okay, looks like we're a lot closer. $69.99, right at 7 there. 98. Let me grab a little bit on this side of the rod, not quite as much. And
these are the ones I've been wearing.
okay, let's see what we got here. $69.99. Yeah, I think I'll stop there. That's close enough. Everything's still looking good there. But that's how you wedge them back apart if you go a little too far. Just get you a couple wedges. You could make them out of, you know, some steel stock or something if you want, but they're really not that expensive. Okay, so let's see what we ended up with. I got a good tight 19.48. So we actually spread it apart 2 thousandths. So $69.99. Okay, time to get it in the lathe and start taking the run out of it. Okay, like I do every time, I cut my own center. This has worked for me for years. I know I could put a regular center in there with an adapter, but this works for me. It just takes me a few minutes to cut it each time. That way we know it's straight. Looks like I need just a little bit more here. I've actually got a center and an adapter, but you know, it's foreign made stuff, and I've just never been happy with the run out that I get with it. And this way I know I'm good. You know, for most machining things that I do, I don't need to be that critical for most things. But for crankshafts, I like to always put my best foot forward and make sure that I'm getting the best results that I can. Okay, got it set up here in the lathe. Let's see if we can get it zeroed out here. It's the left side's okay, 0. It's not off very much. Well, 5 over here and 4 over here. Okay, let's work the this side here. So we've got right here. It's where we need to whack it. We want to drive it this way. Okay. And drive it right there. Put it back in. See if we've done anything. I have to kind of hold on to the rod here. It's a little longer than usual. Okay, looks like we've got 4 out of it here, so we took care of 1/1000ths, and it's moved this side a little bit. 4, still 4 on the clutch side, and now it's 4 on the mag side, and we're still at the same point, so we'll pop it out of there and do it again. This went together real hard, so it's going to take some pressure to move it. So back in. Always put it back in the same way. Okay, we're at about 3.5 on this side now. And this side is moved. Re-zero it. Still 4. And you see we've got preload on them too, so you always want to make sure you preload those gauges, otherwise you're not measuring anything. Okay, 3.5, and I've got a little bit of, I've got 1 at the same time there, so we must have a little bit of spread, but we'll take care of that a little bit later, I think. Okay, let's, we're essentially at the same spot still, so let me whack that again. about 3.5 on both sides right now. And we're still at the same place, so I'll give her another hit. Okay, we're 2.5 on the mag and 3 on the clutch side. And here again, we're still at that same point, so we just need to drive that a little bit more. All right. Okay, we've got something else going on now. You notice that both of these dials are going to the right at the same time. So that's telling me that we've got a pinch. And it's right down here at the bottom. You know, you take a look at the indicators right here. They're both to the right. So we need to spread it down here at the very bottom. So let me pop it out of there. We'll take it over to the bench. I'll show you what we need to do. Okay, I marked it right here. So here's where we need to spread it. We're going to verify this first. See where we're at here still. Okay, 69.99. Yeah, 69.96. It's not much, but we just need to spread it a little bit. So again, I like 2 of them in there. And now this you don't want to get too overzealous with. And you don't want to keep doing stuff without checking. Always go back and check. Okay. Let's see what we got now. Oh, that's good. Okay, we've got just a little movement of the needle there, staying right on 0 though. And on the clutch side, we're at 1. Let me back you out here so you can see the whole thing. Okay. So we've still got preload, still got preload. We're just kind of moving on the mag side, and we've got 1/1000ths over here. So you can tell that doing that spread was pretty much the finishing touch, and we're in really good shape there right now. That's good. Most of these are acceptable at 2, and we're at 1. I will look up the criteria and make sure. Okay, we've got our Suzuki service bulletin, RM 400T. It's the 80 model. I'm sure the 79 is the same. Here's our crankshaft data. We've got big end side clearance that does not specify. So remember we had 24/1000ths on the old one, and on the new one I believe it was 17 or 19 I think it was. So that's not, it's not relevant at all. You want this 70.0 plus or minus 0.1 millimeter web width. That's what you're shooting for. But here's our crankshaft run out right here. And the limit, this is the limit, this is standard, 0.05 millimeter, so 2/1000ths. we're half that. We're at 1/1000ths, so we're in good shape. Okay, the other thing that's of consequence is the conrod deflection, and the limit is 3.0 millimeter. So let's go over and check and see what we got on that. Okay, let's get this up here. I've got it pulled all the way to the left, mag side, and we're zeroed out. 40/1000ths. So the limit is 3.0 millimeter or 0.118, so 118/1000ths, way within the tolerance. 40/1000ths. Well, there we are, guys. Pin's nice and flush over here. Same on this side. And we've got our proper width, 69/98. 70 millimeters is our target, plus or minus 0.01, I think it was, or maybe it was 0.1. 0.1, I believe. Yeah, 0.1. And you know, like I said, this type, the piston centers everything, so you've got all this to start with. And our what they call shake, this measurement here, the limit was 0.118, and we were at about 40/1000ths. So we're good to go on this. Oh, and we had 1/1000ths run out. So we're good to go on this one, and we'll be starting to build on the RM400T pretty soon. So we've got it bagged up, and that way it'll stay clean until we're ready to build the thing. Okay, guys, there you have it. The RM400T crankshaft build. I've already got the cases cleaned up, and I've got bearings installed. I've still got to put the seals in, but we'll be building that pretty soon. Not sure what we're going to do next, but I just thought I'd do some engine work for you guys, and you know, maybe break up a little of the monotony. One thing I'm going to do here that you've probably never seen me do before is I've got a friend of mine that's got a TS250 Suzuki 69, I think it is. I'm going to run some pictures of it right now, and you can find his email in the description block of this video, and you can contact him there, find out what he wants for it. It's for sale. I really don't know anything. The only thing that I know is the pictures that I've seen. Looks really nice, but you're going to have to deal with him. But his email will be in the description block of this video. So go there and give him a shout out and find out if you're interested in a nice TS250. Okay. Hey, thanks for going along on the ride. See you next video.